Hey, hi all. Welcome back to BRL Knowledge Center. And this today's session, we're going to talk about .NET compilers. Please subscribe this channel. If you're not review or listen the previous recorded videos, please go to the BRL Knowledge Center YouTube channel and see the C .NET course playlist. So, coming to this .NET compilers, .NET is basically compiler based translator. We are having it to convert our high level language. Whatever program you are writing in English is going to be converted into native code using compiler. So in the compiler itself, we have different compilers in .NET. Okay, so we'll talk about those. In .NET framework, when you compile your program, right, it will not directly convert your program into native code. Instead of converting into native code, it first convert your compile or your high level program into the Microsoft Intermediate language code. Okay, let us take an example. I have a program void main, right? Arguments string. So if you look at this is what my simple program. Welcome to .NET compilers. So when I compile this program, okay, this program is not going to convert directly into native code. Okay, first it will convert into Microsoft Intermediate language, that is MSIL. Okay, so MSIL means Microsoft Intermediate language. So when you compile your program using .NET compiler, right, it is going to convert your this particular program into MSIL code, Microsoft Intermediate language. Okay, so once after this, right, this .NET specific compiler comes into the picture, and it will take this MSIL code and then it will conforms to JIT compiler. Okay, it will informs to JIT compiler. The JIT compiler is going to convert your MSIL code into native code, which is CPU specific code that runs on a same computer architecture. Okay, so let me talk about this. In .NET framework, when you compile your program, it did not immediately create OS specific native code. Instead, right, it first compiles your code into MSIL, that is Microsoft Intermediate language. So usually all .NET languages like C#, VB.NET, and F# or JavaScript, right, such as C#, VB, J#, right, are initially compiled into MSIL by CLR compiler. What is this CLR compiler? CLR is nothing but Common Language Runtime. Okay, that means we have a common language runtime for a .NET program, which is taking your program and takes the ownership of a program and then converts into MSIL. Okay, so the .NET languages, right? The .NET languages conforms to the CLR, right? Uses its corresponding runtime. So each language here, these are the languages I told you, right? Each language is having its own runtime and compiler. The .NET language conforms to the CLR, uses its corresponding runtime, which is responsible, right? Which is responsible, uh, you know, which is responsible to run the application. on different OSs. Okay, so how it is going to convert a native code? So with the help of JIT compiler, that is just in time, right? The common language runtime doing tasks. So JIT converts the MSAL code into native code, which is CPU specific code that runs on the same computer architecture. Understood? So the .NET framework is not going to convert your program directly into a native code. Okay, this will convert into MSAL first. That MSAL is going to convert into native code with the help of a JIT compiler. Okay, so if you want to me show this diagram, right? You can see this diagram, right? If you look at this diagram, these are the different .NET languages, right? This .NET language having specific compilers. This is specific compiler C sharp. This is CSC. We can call it as C sharp compiler. This is VBC, VB compiler, JSC, and F sharp like this. This particular compilers will convert this code into MSI, CIL or MSIL, both are same. Common Intermediate Language or Microsoft Intermediate Language. These things can create exe or DLLs of your code, and that code is passing it to a JIT compiler. JIT compiler will convert it to native code, and then it start executing it. Okay, so coming to here, so that's what I'm talking about here. Okay, that's what basically I'm trying to explain it here. This is the flow happening inside of your .NET compiler. Okay, so when it comes to this JIT compiler, we have different types of JIT compilers. We having that. The first one is normal JIT. Second one is ECNOJIT, and third one is pre-JIT. Okay, so when it comes to normal JIT, right? So it compiles, right? The methods, it compiles the methods at runtime. It compiles the methods at runtime, and then they are stored or storing into memory cache. So this memory cache is commonly referenced as JIT. Okay, so once stored in cache, right? No further compilation is required for the same methods. Subsequently, right? Subsequently, method calls are accessible directly from the memory cache. So this is one of the advantages of a normal JIT. So normal JIT basically compiles, right, the methods at runtime and keeps into the memory cache. Let us take an example here. I have a method, M1 method, right, and M2 method. So when I call this M1 method, right, or M2 method, at runtime, these methods are going to be compiled and keep into the memory cache and tagged as JIT. Okay, so that these things will get directly fetched for subsequent compilation process. After I made changes to this program and start compiling it, these methods are coming from cache memory. It's not again compiling it. That's what NormalJet is doing it. Okay. And coming to the ECNOJet, this is different to the NormalJet. It compiles, right, the methods when called at runtime and removes them from memory cache once execution completed. So here, this is purely opposite to the NormalJet. Okay, this will compiles methods at runtime when called and removes from memory cache once execution is completed. But here it keeps the compile objects into memory and refer as JITed. But here it won't keep in memory. It will remove immediately once the execution is done. Preset is different. This name itself saying that it will compile entire assembly, right? It compiles the entire assembly into native code instead of used methods. So instead of used methods, it's only compiling it. Like if you look at these two are only compiling used methods. It compiles the methods at runtime and they are storing into memory cache. Only methods it is compiling. This is also compiles only methods and not keeping in memory, and it will remove once the execution done. But it comes into the picture when you call it. Even though I have two methods here along with main method, when you called it only, it will compile these methods and keep into memory and remove once call is done. Okay. And coming to the preset, right? It will compile entire thing at single time. It won't look for whether it is calling or not. It will compile entire stuff instead of used methods. That's what the difference of it. If you look at the diagrams, right? This is what preset is doing it. It will take everything from CIL and compile everything into native code. And coming to the NormalJet, it compiles the methods at runtime and keep in memory cache. For further subsequent compilation, it will fetch from memory cache. And coming to this ECNOJet, it will compile your methods executing at runtime and removes from memory cache once the execution is done. Okay, so this is something about .NET compilers. Like we're basically having a CLR, which is Common Language Runtime, and that is going to take care of all the C#, all the .NET language compilers, and it converts into MSIL or CAL. This can be called as MSIL or CAL. This is Common Intermediate Language. Okay, both are same. And that along with that, it is going to give metadata to describe what exe is basically, what methods it is having it, what parameters it is having it. Metadata is nothing but data about data, description about data, description about code, description about program. This entire thing will get passed to JIT compiler. JIT compiler comes into the picture, and based on the type of program you are writing it, it comes into the picture and it will activate these three compilers. This is for methods. This is for methods, but not keeping caching. This is for entire assembly. Okay. I hope you understood the .NET compilers. Thanks for listening to this video, and please subscribe this channel for more videos. Thank you.